Afternoon, science fans. As you can see up in your top left-hand corner, that is the sun, right? Alexa, how far away can the sun be seen reflecting off of a mirror?
From fastcompany.com. When the sun hits the mirrors, the light and heat are reflected and sent to whichever spot you've designated, up to 25 feet away.
Alexa, what is the maximum distance that the sun could be seen reflecting off of a mirror, please?
From fastcompany.com. When the sun hits the mirrors, the light and heat are reflected and sent to whichever spot you've designated, up to 25 feet away.
It's 100 miles, okay, 160 kilometers. Alexa, can the sun reach 50 miles reflected off of a mirror? What is the maximum distance?
From fandom.com. The maximum range is considered to be 10 miles for each inch of mirror diameter, although with altitude, line of sight is improved and therefore range.
Alexa, if I have a mirror, how far can I reflect sunlight off of it, please?
From housecaravan.com. A mirror can reflect up to 80% of light.
It's really testing sometimes, this is. Alexa, can a mirror radiate the light from the sun 100 miles?
From Brogapen.com. The flash signal mirror is proven to produce sun flash that can be seen for up to 100 miles in the right conditions.
Miles. You see why, can't you? Right? You cannot time or measure the speed of light, right? It can't be done because it's too fast. And any claims that say otherwise should really seriously be properly looked at, because I haven't seen any that are worthwhile following. Right. God. Sun isn't right. Hang on. And then I have to move this shade, that doorbell a bit. Right, the sun's just doing it on purpose, just to mess with us. Well, not with me. I know about the sun. Today, we're going to do something that we've done, or I've done a couple of times before. This time, we are going to use a mirror for the sun. The sun bouncing off of a mirror. So basically, we're using the sun to be the sun. Now then, the sun's diameter, 1,390,000. The distance between Earth and the sun, 150 million kilometers. If we divide the distance by the sun's diameter, we get 108 sun diameters. That is the distance between Earth and the sun, right? It's 150 million kilometers. It's also 108 sun diameters, right? Earth's diameter. This one was just for interest because we're going to see it now. If we divide the sun's diameter by Earth's diameter, we get 109, right? So there are 109 Earth's diameters in one of the sun's diameter, right? Now then, this is where it begins. This mirror has got a diameter of 12 centimeters, right? 12 centimeters. So this is all about the sun. The sun's now 12 centimeters. So we've got to do to everything else what we did to the sun, shrink it down to this size. Now we know that there are 108 sun diameters for the distance, right, between Earth and the sun, right? So what I've done is I've measured, and that is, by the way, 108 multiplied by 12 is 12.96 meters, so I called it 13. that there is planet Earth on that chair, and way over there on the other chair is a mirror and a little orange thing. That is the sun. So that is now the distance between the sun and Earth. 13 meters. It was 150 million kilometers, but we've brought the sun down to 12 centimeters in diameter. So now what we're going to do is do to everything what we did to the sun. So we now have 12 centimeters for the sun. So if we want to find out the size of the diameter of Earth, we divide the 12 centimeter sun by 109 Earths, and that will give us the size. Alexa, what's 12 centimeters divided by 109?
12 centimeters divided by 109 is approximately 1.1009 millimeters.
So 1.1 millimeters, that's correct, that's right. So we've got the distance between the Earth and the Sun is 12.96 meters. The Sun's 1,390,000 diameter becomes 12 centimeters, and Earth's diameter becomes 1.1 millimeters. All right? So everything is to scale. Capiche? Capiche? Just going to take a walk. So here, we have a planet Earth. It's a big one, but these are the bristles from a paintbrush, from a normal brush, right? Now those three together, right? I had a ruler, I could go get the ruler, but you've got to trust me. When they're up together, it's about just over a millimeter, right? So if we got the tip of those, right, turn it into a little ball, that would be the Earth's diameter with a 12 centimeter diameter sun. So this is here, but we're going to use this so that we can see. All right. So that's where Earth is, and we are now going to walk 13 meters, or the 150 million kilometers, to the sun. And here it is. So we have a 12 centimeter diameter sun. All right. Now we don't need that because we've got the real sun, haven't we? You know, it's over there. Get off me, bug. It's over there. So you'll be able to see me here. And what I'm going to do is get the sun reflection. All right. Now, is that or is that not instant? Well, of course it's instant, isn't it? Why are you not getting the... Oh! There we go. That's all that needed to happen. Come down a bit. And that is absolute light. But what they are saying, so that distance, right? Right, of course, it's only 13 meters. It's not 150 million kilometers. Yeah, I get that. But the sun is only 12 centimeters in diameter as well, isn't it? And I tell you what, this isn't a bulb. This is the sun's light. All right? Now that would happen 13 meters away, 30 kilometers away, 130,000 kilometers away, 1.3 million kilometers away, 150 million kilometers away, right? The sun, its light is absolute, right? It's absolute. You cannot measure or time it, right? But the science, well, the science The science says that the light radiating from the sun, now remember, this is to scale, would take 8 minutes and 20 seconds. Should we time it? Do you want to go through the whole 8 minutes and 20 seconds? Let's just do 30 seconds of it from the sun. And we're off. You know what? By the sun, it's taking me 4.6 seconds to radiate my light, each of my one diameter. Right? One diameter, 4.6 seconds. There's 108 of me in between here and there. Looks like I'm exaggerating, but I'm not. Some things defy common sense. Some things are obvious and they defy common sense. This is one of them. The sun's light is absolute. It's instant. There is no measuring and no timing. And if there is, I've yet to see it. And if somebody else has seen it, oh, please let me know. But don't let it be some mirrors being spun around with light traveling in between two wheels. And it's definitely not anything to do with observing Io, as it zigzags in and out from behind Jupiter because it's too small. And as for stellar aberration, well, without any instruments whatsoever, it is just a joke. It's an insult to people's intelligence. It hasn't been timed. It can't be timed. It's ridiculous claims. Look. If you had that 100 mile distance, right, from a mirror shining and somebody 100 mile away, you could put a person at 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, and the last guy, 160. You could have 16 guys with their finger on a button. And when they saw the light from the mirror flash, they were all in a position to see it from where they were. I guarantee there would never, ever be anything other than a random picture. There would never be like, oh yeah, look, the first guy saw it first and the second guy saw it second and then the fourth guy. No, it would be random. The 16th guy might as well could press it at the same time as the fourth guy, or the 10th guy the same time as the first guy. It's that fast. It's absolute. It's instant. And if it's not, prove otherwise. Because all of the stuff that they reckon has been proven has not, because it can't be done. It can't be measured. Everybody just presumes, right? Like I said before, presuming is not enough anymore. Show us how it was done. That cannot be measured. It's absolute. It's beyond measuring. It's beyond timing. It's beyond everything we know. People need to stop making claims that can't be made. Saying they've done this and they've done that and they've discovered this and they've discovered that. The sun's light, right? There's so much that comes into play in our life with this speed of light. And it's wrong. And if it isn't wrong, then where is the study that shows that it travels at 299,792 kilometers per second? Where is it? Where is it? Because that 299,792 kilometers per second dictates that the sun takes 4.6 seconds to radiate its light the distance of its diameter, and that is ridiculous. At the speed of light, with a diameter of 1,390,000 kilometers, it would take the sun 4.6 seconds to radiate its own light the distance of its own diameter. It's an insult to people's intelligence. Coming up to 15 minutes, quarter of an hour. The sun's light is absolute. Somebody needs to prove otherwise. Later, peeps.